Hello everyone, welcome back to Embedded System course practicals. So today we are going to study practical number 5. So its title is Development and Execution of Program in C to generate square wave at 8051 port pins using timers, or in other words we are going to study timer programming in this practical number 5. Okay, so that timer we can configure as a timer to produce or generate a precise time delay, or we can use timers to use it in a counter mode to count the events that are happening outside 8051. Okay, so there are two timers, timer 0, timer 1 in a generic 8051 microcontroller. So we can program these two timers either in timer mode or counter mode. Okay, that is to generate precise time delay or to count the events that are happening outside 8051. Okay, so under this we are going to study three programs. First program is write 8051C program to toggle only bit number 5 of port 1 continuously after every 500 milliseconds. For that, to generate this 500 millisecond, use timer 0 in mode 1 to create the delay. Mode 1 is nothing but 16-bit mode. Okay, so in this first program we have to configure timer 0 in timer mode because we have to produce or generate a delay of 500 millisecond. Okay, so this is the first program. So after 500 millisecond we will toggle pin number 5 of port 1. That is the objective. Then next program number 2, write a 8051C program to toggle all the bits of port 2 continuously after every 250 microseconds. So there are 8 bits or 8 pins of port 2. So we have to toggle all the pins of port 2 continuously after every 250 microseconds. To generate this 250 microseconds time delay, we have to use timer 0 in mode 2, which is nothing but 8-bit auto reload mode. Okay, so that is the second program. So first and second program, in these two programs we will study timers of 8051 in a timer mode. Okay, in program number 3, assume that 1 Hertz external clock is being fed to pin number T0, that is pin number 4 of port 3. So T0 pin is being fed with a 1 Hertz clock, means 1 pulse per second is being applied at pin number 4 of port 3. Okay, which is also act as T0. Okay, that is timer 0 input pin. Okay, so when we configure timer 0 in counter mode, whatever pulses that will get applied on T0 pin, that will get counted inside in timer 0 register. Okay, so write a 8051C program for counter 0, that is timer 0 in counter mode, to count the pulses in TS0, TL0 and display TS0, TL0 count on port 2 and port 1 respectively. Means we have to configure timer 0 in counter 16-bit counter mode. Okay, so in this way we can count the pulses we are applying, external pulses that are being applied on T0 pin, which is nothing but pin number 4 of port 3. Okay, so these pulses will be counted in TH0 and TL0. Okay, and parallelly we are going to output the count in TH0 and TL0 on port 2 and port 1 respectively. That is the program number 3. So in program number 3 we have to configure timer 0 in counter mode, while in first and second program we are going to configure timer in timer mode. Okay, so these are the three programs we are going to study. So I have already written these programs. Okay, so I have created program files, program 1.c, prog2.c and prog3.c, and I have created project file. Okay, so let us study these programs one by one. So I will open project file. Okay, so this is the project file prj5. I have already created, and under this I have created program number 1, prog1.c. Okay, so that is the first program. So this is the title of this practical number 5, and this is the program number 1 title. Write a 8051 C program to toggle only bit 5 of port 1 continuously after every 500 millisecond. Use timer 0 in mode 1, that is 16-bit mode, to create the delay. Okay, now when we want to use timer 0 or timer 1 in a timer mode, that is to generate a precise delay, then depending on how much delay we want. So right now here we want 500 millisecond, okay, delay. Now to generate this delay, precise delay, accurate delay, we have to load the initial count value into timer registers. Okay, in this case we are going to use timer 0, so we have to determine the initial count to be loaded into TL0 and TH0 timer 0 registers, initial count, and for that this that is how much time delay we require, that is important. Okay, so the steps to calculate the initial count to be loaded into timer 0 registers in mode 1 that are given. So for that we are assuming that crystal that is connected to 8051 microcontroller, it is equal to 11.0592 megahertz. Okay, so we are assuming that crystal frequency 11.0592 megahertz. Accordingly, that is a 1 machine cycle. Okay, so or internally that frequency will get divided by 12, and that will be used as timer clock frequency. Okay, so that if 11.0592 megahertz is divided by 12, okay, so whatever frequency we will get, its time period, that is nothing but internal timer clock period, so that will come 1.085 microsecond, 1.085 microsecond. Okay, now to determine the initial count to be loaded into timer register in mode 1, okay, following are 4 steps we have to take. Okay, first is divide the desired delay by 1.085 microsecond, because this is nothing but 1.085 microsecond is nothing but 1 divided by 11.0592 divided by 12, and that frequency's time period is 1.085 microsecond, because that is the clock timer clock frequency internally used by timers of 8051. Okay, so first divide the desired delay by 1.085 microsecond. This is the first step. Then perform this calculation 65,535 minus n, where n is the decimal equivalent of value we are getting in step number 1. Okay, that is after dividing desired delay by 1.085 microsecond, whatever value we get. Okay, so decimal value, that is nothing but n plus 1. Okay, so here we are performing this calculation, and after this calculation we'll get decimal value. Convert that decimal value we have got in step number 2 to equivalent hex. Okay, and if we are getting that equivalent hex value YYXX, okay, then that YYXX is nothing but the initial value to be loaded into timer 0 registers. Okay, so TL or TL0 will get loaded with XS. Okay, that is a lower 8-bit number XX, and TH will get loaded with the YY, that is higher order 8-bit number from this YYXX. Okay, so that values you have to load in TL0 and TL0. So these are the 4 steps you can take to determine initial value to be loaded into timer 0 or timer 1 registers of 8051 when we configure these timers in 16-bit mode. Okay, to generate a desired time delay. Okay, now in our case, in this program, how much delay we want? We want 500 millisecond. Okay, so for that we have to determine the initial count value to be loaded into TH0 and TL0, because we are going to use timer 0. Okay, so according to above 4 steps we will do calculations. So in first step, that 500 millisecond, that is the desired delay we want to generate, that will get divided by 1.085 microsecond. So what value we get? 46,008 no 4,60,829. Okay, so that is a very big value, and that is a actually in second step that we are going to subtract from 65,535, but it is well above this 65,535. Okay, so we cannot, that means we cannot we cannot generate a delay. Okay, so this 500 millisecond divided by 1.085 microsecond, so this value is bigger. Okay, that means by loading the value in TL0 and TL0, okay, maximum value, for example, in that case, if timer 0 is configured in 16-bit mode, then what value we should load in TL0 and TL0 to generate a maximum delay? So that value is 0000. Even if we load 0000 in TL0 TL0, that will not generate this much delay, that is 500 milliseconds. Okay, so for that one trick, what we are doing, we are just dividing this value we are getting in step 1, that is 4,60,829, just by 10. Okay, so what value we are getting? 46,083. Okay, so that is a less than this 65,535, so it can get subtracted from this 65,535. Okay, so we divide this value by 10. Okay, so we will get 46,083, so that will get subtracted and which is added with 1. So what value we are getting? 19,453. Okay, so if we convert this to equivalent hexadecimal in step 3, I will get 4BFD. Okay, so I will load FD into TL0. I will load FD into TL0, and I will load 4B into TL0. Okay, and then if I start timer 0, what will happen? How much delay it will get generate? It will generate delay equal to 500 millisecond divided by 10. 500 millisecond divided by 10, because for 500 millisecond count is 4,60,829, but we have divided that count by 10. Okay, so if this initial count we load in TL0 and TL0, and if we start timer 0, okay, so rollover occurs after 50 milliseconds. Okay, so that means timer 0 we have to call that timer 0. Okay, to generate 50 milliseconds of delay, we should call how many times? 10 times, so that it will generate 500 millisecond delay. Okay, so to generate delay of 500 millisecond, we have to repeat the timer 0 delay 10 times. Okay, so timer 0 registers will get loaded with FD, that is TL0 will get loaded with FD, and TL0 will get loaded with 4B, so that will be fixed, and this timer 0 time delay we will call 10 times, so that it will generate 500 millisecond delay. Okay, so this is delay calculation. Now the program. So hash include reg51.h as usual, then s bit my bit is equal to p1 caret 5. Okay, so p1 caret 5 is the address of pin number 5 of port 1 that is being applied, that is being assigned to my bit, that is s bit type of variable. Okay, so that I can represent pin number 5 of port 1 by using symbol my bit. Okay, then void timer 0 underscore delay void. Okay, so whatever program that is written for timer 0 to generate delay of 50 milliseconds, so that is written in this function having name timer 0 underscore delay. Then the main program, so in main function unsigned char z is being declared as unsigned char type of variable. Then my bit is equal to 0, so I am configuring this pin number 5. My bit is what? It is pin number 5 of port 1, so I am configuring this pin as output pin. Okay, and then while one means this is whatever enclosed in between this opening and closing braces, that will be repeated infinitely or continuously. Okay, so what I'm doing, my bit is equal to 1 semi-comma, means I'm making this pin number 5 of port 1. Okay, and then I'm calling timer 0 underscore delay subroutine. Okay, so this is for loop, so it will repeat until value in Z is less than 10 and Z is initialized with value 0. Means this for loop will be repeated how many times? 10 times. Okay, and this timer 0 delay function is generating delay of 50 milliseconds. Okay, means this for loop will generate, or this for loop will call this function 10 times, means it will generate 50 millisecond multiplied by 10, that is 500 millisecond delay. Okay, then my bit is equal to 0. After that I am toggling this my bit, okay, because that is been asked. I'm making it is 0, and again I am calling same for loop. Okay, so it will generate 500 millisecond, and that will be continuous. Okay, so continuously whatever program in a while loop, it is being repeating. Okay, and it is toggling pin number 5 of port 1 after every 500 millisecond. Now we will go inside this timer 0 delay function. Okay, see here, so this timer 0 delay function will generate 50 millisecond delay. Okay, so see the program. T mod is equal to 0x01 semicolon. So I am loading value 0x01 into T mod, timer mode selector control register. Okay, so this is SFR T mod. In this I am loading 0x01, means I am configuring timer 0 in mode 1. Okay, if I load 01 into T mod hex, then initial count I'm loading. Okay, TL0 is being loaded with 0x4AB and TL0 0xFD that we determined for 50 millisecond time delay. Then I'm turning on timer 0. Okay, so from this initial count, that count in TL0 will start incrementing. Okay, and after that, while TF0 is equal to 0, okay, means until TF0, that is timer 0 flag bit is 1, that will be in loop. Okay, so this while loop will be executed until this TF0 is 0. Once it becomes 1, when this TF0 will become 1, when count in TL0 and TH0 rollovers from all ones, that is FF to 0000 due to next timer clock pulse. Okay, when this happens, that means when this happens 50 millisecond delay is reached. Okay, so your program will come out of this while loop, and TR0 is equal to 0, means timer 0 will be stopped, and TF0 will be 0, means timer flag that was set. Okay, that again we are resetting for next um, call of this timer 0 delay function. Okay, in this way, this when this timer 0 delay function execute for once, 50 millisecond delay gets generated. In this way, this timer 0 delay we are repeating 10 times after toggling this pin number 5 of port 1, that is my bit. In this way, it will generate 500 millisecond delay. Okay, now we will build this program. So there are no errors. Now we can check the output. Okay, so we are interested in port number 1. Okay, I will close this. Okay, and here I can also check the output on pin number 5 of port 1, which is named as my bit. Okay, so that my bit, I can watch output here in this analyzer. Okay, logic analyzer, and parallelly I can also check the output here. That is pin number 5 means this 0 1 2 3 4 and 5. Okay, this bit we have to check. Now I will run the program. Okay, so it is continuously toggling after 500 milliseconds. So here, so I will zoom out so that, see here, after 500 millisecond this pin is toggling, that is my bit. Okay, so in this way this program is toggling pin number 5 of port 1 continuously. Okay, so with a 500 millisecond delay in between. Okay, so you can directly check bit here, or you can use logic analyzer. Okay, so on my bit pin, whatever logic, okay, that is switching in between 0 and 1. It is toggling in between 0 and 1 after each 500 milliseconds. Okay, so this is the first program. Okay, so we will proceed to next program. So I will stop this debugging session. I will remove this program number 1. I will add next program, program 2, which is already written. Okay, so this is program number 2. So what is program number 2? Write a 8051C program to toggle all the bits, all the pins of port 2 continuously after 250 microseconds, and for that use timer 0 in mode 2, which is 8-bit auto reload mode. Okay, mode 1 was 16-bit mode, but mode 2 is 8-bit auto reload mode. Okay, and we have to use this mode to create a delay of 250 microsecond. Okay, so that is the task. Now to generate this 250 microsecond delay, okay, we have to repeat the steps that we studied, okay, to determine the initial count to be loaded into timer 0 registers. Since the timer 0 is being used in mode 2, okay, we have to load only one timer 0 register, that is TH0 initial count. Okay, we have to load in only TH0 timer 0 register. Okay, because it is 8-bit auto reload mode. Okay, so for that steps, same steps. Okay, only slight difference is there. Okay, so follow the steps below to find value to be loaded into TH register. Okay, so here not TH, THX. Okay, so assume crystal frequency 11.0592 megahertz. So first step is divide the desired delay by 1.085 microsecond, because crystal frequency we are assuming 11.0592 megahertz. So after that perform calculation 255 minus n plus 1, where n is the decimal equivalent of value we got in step number 1. Then convert the result of step 2 in hex. Okay, that is YY in hex if we get number YY. So that is the initial value to be loaded into timer register. Okay, so TH register either of timer 0 or timer 1 we are using, that should be loaded with this hex value, that is YY. Okay, now we are going to perform this calculation for the delay of 250 microseconds. Okay, so these 250 microseconds first get divided by 1.085 microsecond, so we will get 230.42, that we have approximated to 231. Then in step number 2, 231 is nothing but value n, so we will subtract it from 255 and we will get we will add 1 into it. Okay, so 255 minus 231 plus 1, we get 25. Okay, so convert this 25 decimal to hexadecimal. So 19 is the hexadecimal equivalent of 25 decimal. So load this 19h into TH0, that is the initial count to be loaded into TH0 register. Okay, so to generate 250 microsecond delay, okay, by timer 0. Okay, so now main program hash include reg51.h void timer 0 delay void. So this is the function in which I am programming timer 0 to generate 250 microsecond delay. Okay, and then this function I am calling. Okay, then void main void. So port 2 is being outputted with value 55. 0x55 means 0101 0101. Alternate bits of port 2 are toggled here. Okay, then while 1 means this is an infinite while loop, so whatever enclosed in this while loop, that will be repeated continuously. Okay, so port 2 is equal to tilt port 2. So what is this? This tilt is a not or complement operator. Okay, so it will operate on data in port 2. So what we have loaded in data in port 2? 55. So if we complement it, 55 means what? It is a 0101 0101. Okay, so if we complement it, so what I will get? 1010 1010. That is nothing but in hex AAH. Okay, AAH. So what we are doing, we are just toggling data in port 2. Okay, by using P2 is equal to tilde P2, means whatever data in port 2 that will get complemented, means we are toggling all the bits of port 2. Okay, so AAH will get outputted to port 2. Okay, and then we are calling this timer 0 delay. Okay, so timer 0 delay function will generate delay of 250 microseconds, and after that again this P2 is equal to tilde P2 will be executed. So again AH will get complemented to 55H, and that will get outputted to port 2. Again this same timer 0 delay function is calling, okay, which will generate 250 microseconds. So this will continuously happen, means whatever data in port 2 that will get toggled after every 250 microseconds. Now see the timer 0 delay function, what is programmed inside this. So t mod is equal to 0x02. Okay, that means if we load 0x02 into t mod, it will configure timer 0 in timer mode 2, that is 8-bit auto reload. Then we are loading th0 with initial count 0xe9. Okay, sorry, it is 19, it should be 19 here, 19. Okay, so that is typographic mistake. So here it should be 0x19, th0 is loaded with 0x19. Parallelly it will get loaded into TL0. Okay, that is 0x19. After that we are turning on timer 0. Okay, so when timer 0 gets turned on, what will happen? Count in TL0, which is 0x19. Okay, that will start incrementing with each timer clock frequency pulse. Okay, so that data in TL0 will remain unchanged, that will remain 0x19, but data in TL0 will start incrementing from 0x19. When after that your program will be continuously in loop monitoring TF0 flag bit. Initially it is 0. Okay, and when count in TL0 reaches maximum value, that is FFH, and due to one more pulse it will get rolled uh, roll to 0 0. Okay, then this TF0 flag bit will get set. Okay, and your program will come out of this while loop and will go to the next statement below. Okay, so when this TF0 flag bit gets set, okay, your program will come out of loop, and the time delay that generated, that will be equal to 250 microseconds. Okay, so after that we are stopping timer 0 by making TR0 bit 0, and then we are also resetting TF0 flag bit, which was set due to roller of count in TL0, and after that again value in TH0, that is 0x19, gets reloaded into TL0. Okay, and program control will get transferred to the main program. After that data in port 2 again get complemented, and again this timer 0 delay will get called, and again it will give us delay of 250 microseconds. In this way the data in port 2 is being toggled after every 250 microseconds. Okay, now we will check the output of this program. For that I will build this program. So there is an error. So that error is on line number 33. Okay, so here while 1. Okay, so here we typed something. Okay, so we have to remove that and we will build. No errors, 0 errors. Now I will start debug session. Okay, now I will check port 2 data. So peripheral IO ports port 2. Okay, and I will just run the program. Okay, now see. So this data is being complemented after 250 microseconds. Okay, so we can step execute this program. Okay, so I will come out of this loop, and again I will step execute. Okay, so here step over I will use. Okay, so first this port 2 will be outputted with data 55H here, then after that it will get toggled. So so continuously up to 250 millisecond it is being toggled. Okay, see here, I'm not going inside this timer zero delay function. For that I'm using this step 4, okay, execution, okay, so that I can see the output. So after 250 microseconds, that data in port 2 is being toggled. So we are getting output. Okay, so this is program number 2. So let us move to program number 3. Okay, so I will remove this program number 2 and I will add program number 3 now. Program number 3. So see what is program number 3. So assume that 1 hertz external clock is being fed to pin number 0, okay, of uh, pin number 4 of port 3, that is T0 pin, which is T0 pin. Okay, write a 8051C program for counter 0, that is timer 0 in counter mode, to count the pulses in a TS0 TL0 registers and display TS0 TL0 count on port 2 and port 1 respectively. Okay, that means we are going to use timer 0 in 16-bit counter mode. Okay, so in that mode, whatever pulses are that are being applied on pin T0, that is nothing but pin number 4 of port 3, that will be counted in TH0 and TL0 registers. Okay, and this count in TH0 TL0 registers we have to output on port 2 and port 1. So for that program is written hash include reg51.h. So this part is not required. It is not required to define T0. Okay, because it is already defined in reg51. T0 means what? It is pin number 4 of port 3. So void main, void inside this main function, see what is written. So T0 is equal to 1 semicomma means we are configuring this pin T0, that is pin number 4 of port 3, as input pin. Okay, then T mod is equal to 0x05. Okay, so when we load 0x05 in T mod, that will configure timer 0 in a 16-bit counter mode. 16-bit, that is mode 1 of counter mode. Okay, then initial count we are loading in TS0 and TL0, that is 0000. Okay, because we are going to count whatever pulses we are receiving on T0 pin into this TS0 and TL0. So initial count should be 00. Then while 1 means this is infinite loop, so whatever statements inside this while loop, okay, that will be repeated continuously. TR0 is equal to 1, we are turning on timer. So when we turn on this timer 0, what will happen? Since we have configured this timer 0 in counter mode, 16-bit counter mode, and when we start this timer 0, what will happen? So whatever pulses that are being applied on T0, for example 1 hertz clock pulses are being applied on pin T0, that will start incrementing count in TL0 and TL0, means whatever pulses that are being applied on T0 pin, that are being counted in TL0 and TH0 registers. Okay, so for that we have turned on timer 0, and then while TF0 is equal to 0, okay, means when this TF0 will become 0, 1, when it will get set, when count in TL0 and TH0 rollovers from all ones, that is from value FF to 0000, then it will set. Okay, so while TF0 is equal to 0, म्हणजे जोपर्यंत ती व्हॅल्यू रोल ओव्हर होत नाही तोपर्यंत व्हॉट वी हॅव टू डू, सो व्हॉट एव्हर एनक्लोज्ड इन दिस between opening and closing braces, that is P2 is equal to TH0 and P1 is equal to TL0, means whatever count in TL0 and TH0 we are continuously outputting to port 1 and port 2. Okay, and after that when rollover occurs, means TF0 flag bit gets set, this while loop will get terminated, and then we are stopping timer 0 and we are clearing TF0 bit, and again it will be repeating, again we are starting timer 0. Okay, and again that count will start incrementing from 0000, okay, continuously. Again when it rolls from all ones to 0, again we are clearing TR0 bit, means we are stopping timer 0, then we are clearing TF0 bit, and again that process will repeat. Okay, now we will see the output. Let us check for errors. We will build it. So no errors now. So we have to input pulses at pin number 4 of port 3, that is T0. So I will start debug session. Okay, so on port 1 and port 2, we are going to output uh, count in TL0 and TS0. Okay, so TL0 count is being outputted on port 1. Okay, and TS0 count is being outputted on port 2. Okay, and we have to input pulses on pin number 4 of port 3. Pin number 4 of port 3, isn't it? Yes, that is T0 pin. Pin number 4 means which? 0, 1, 2, 3, 4. Okay, now I will run the program. So initially count should be 0. Okay, so I will run. Okay, so initially count is 0. Okay, now physically we are not applying any pulses because this is simulation. Okay, now what I can do, I can make here pin number 4, 0, 1, 2, 3, 4. I can apply pulse here. Okay, now see here, if I make it 0, so that count in TL0 will get incremented by 1. Okay, and count in TL0, that is 0, 0, 0, 0, 0, 0, 0, 1 is the count due to one pulse. Now if I again apply one more pulse, that count will again get incremented by 1. Now it is 0, 0, 0, 2. In this way, when low to high going pulse is applied on pin number 4 of port 3, that is T0 pin, the count will get incremented by once here. Okay, so it is being incremented as we apply pulses. So this is simulator. Okay, so practically we can apply that 1 hertz pulses on pin number 4 of port 3, that is T0. That will be counted in TL0 and TS0 timer 0 registers, because we have employed timer 0 in counter mode to count these pulses. Okay, and parallelly we are displaying this count in TL0 TS0 on port 1 and port 2. Okay, in this way you can check the output. Okay, so this is a program number 3, that is a configuring timer 0 in a counter mode, 16-bit counter mode, to count the events that are happening outside 8051, and these events are being inputted in the form of pulses like 1 hertz pulses as stated in the program, and that can be counted by timer 0 in counter mode, and that can be displayed on port 1 and port 2. Okay, so this is program number 3. Okay, so any doubt you can ask me on WhatsApp, or you can call me. Okay, so I will stop here.